is needle in a haystack scenarios. So we have that toolkit, and that is environmental DNA as well. So what we can do is we target the sedimentary eDNAs because seahorses always are found within the benthic region in the area. So what we move on to is more of the method development section. And we collect sediment samples from populations of both hippocampus and gutulatus from tanks, make sure that they are specific to that level of genus level, and we can extract some DNA from tissues of pipefish and seahorses just to make sure that they are specific. We can then move on to actually include surveys and trials, and as you can see here from this, what we can do is we collect the sediment from the environment, extract the DNA, create 20,000 nanodroplets. So essentially that is creating the needle in a haystack scenario. So even if one or two of the potential droplets are positive, we are then able to detect the seahorse within that. You then read that and then analyze the results. So this is an actual result from the digital droplet PCR machine. Anything above this cloud is positive seahorse. And so we can move that on to testing out in situ. So we went down to Studland Bay, which is where hippocampus and gutulatus are found in the area of South England, and we sampled systematically throughout a region, and we found 4 positive samples out of the lot. So we're getting very, very high site specificity for seahorses within that area. We can then move it on to Ababican Bay, which is further towards Cornwall and the southwest of England, and we didn't spot a seahorse in this area, and we weren't sure. We've done some habitat suitability modeling, and we were confident that there should be some seahorses found there. So what we did is we went along a 120-meter transect and collected sediment from every 10 meters away. And we were finding 6 out of the 13 samples that we found there. So it's just another method of being able to find seahorses in an incredibly turbid and quite a difficult area geopolitically to try and find. So yeah, any questions?
Super cool. I'm really new to eDNA, and I'm going to ask you a bunch of questions later after this. But my first one is, how much sediment do you have to grab from each of your cores? And just ballpark, how much did it cost to run this, like your study? This, if I were to budget for a grant, how much would that cost?
So, very good questions. So the kit that we're using is 0.25 grams worth of sediment. So it's very, very little amounts of sediment. What we can take is, mostly we've tried to take around 8 to 10 mil, just so that we have enough as a bank for future preservation and that kind of thing. But yeah, it is only 0.25 grams worth of sediment that's extracted from. And then you can get copies numbers of up to 9,000 per gram in that sense. And so for the costings, for the total thing, if you're doing if you have all of the equipment, I don't know how much the equipment costs, but it's around £3, so €4 probably, per sample, yeah.
Any other question?
Yes. Why 10 meters apart?
Please take the microphone.
If I understood correctly, you took every 10 meters a sample. Why 10 meters and not 12 or 15?
We just wanted to make that more systematic for the area that we were testing to get out to the area. At this point, it got to around 25 meters in depth, and that was our cutoff for that. For this one, this is a 300 meter by 300 meter grid. Great.